Okay, here we go, section 7.2, the elimination method for solving systems of equations. So I really like this method. I think it works out super nice. It definitely has its advantages and it occasionally has some disadvantages, but it is a really good method. We'll see another really good method when we get into section 3 called the substitution method. They both really have a time and a place. So the elimination method, I have the steps listed here that you're going to want to go through, and then I have an example. We'll do some more examples too. So, get these steps written down so you can have them ready when we get into the other examples. But here we go. Step 1, we're going to want to line up like terms. So we're going to be looking at systems of equations where we have two equations. You want your x's, your y's, and your just plain numbers all to be lined up. That's going to be the first thing we need. Step 2, we need to multiply, and it's going to be either one equation or both equations, and we'll look at examples of both, to make one variable be opposites. In this case, we already have opposites. You can see I have a plus y and a minus y. So those two things are opposites. Step 3, we're going to add the two equations together. Since everything is so nicely lined up, we're just going to go right down the line and add those like terms, which is legal because of the equal signs. Remember when we solve equations, we said, hey, you can do, as long as you do the exact same thing to both sides, it's perfectly legal. Well, here's an equation. If I add the same thing to both sides, it's legal. Well, here are two things that we are saying are the same because of another equal sign. So we're adding the same thing to both sides. It works. X and x gives us 2x. Y and minus y makes 0y. Now, I left that in here just so we could see it. Normally, when people do that, they just drop it right out completely and they don't even bother putting it in there, and that's perfectly fine. I just wanted us to see the y and the minus y making 0 so that we know that those y's are gone. And then finally, 7 and 1 made 8. Step 4, we solve. We now have a little tiny equation with just x in it. There's nothing special about x. We got rid of y. We could have gotten rid of x instead, but we have x here. So we divide both sides by 2, we get 4, and we go, great! Here's the kicker. Don't stop. Okay? That's not the end of the problem. We need an ordered pair. We need both x and y. If we only have one, we're only halfway done with the problem. So we still have some work here that we need to do. So now we're going to plug it in. We take that 4, and I plugged it into this first equation right here. So in place of x, I now have a 4. 4 plus y is equal to 7. I solve that, subtract 4 from both sides, and I get 3. Make sure the last thing you want to do then is to take your x and your y and combine them to be an ordered pair. And that's our solution. So that's the basic premise for how this is going to work. We're going to look at some harder examples here next. But again, get those steps written down, pause the video here and write those down, and we'll move on and try some harder ones. All right, here is my next example that I want to work with. We have x plus 3y equals negative 4, and then x minus y is equal to 4. Ignore those parentheses for just a second. I threw them in there when I was actually working on the problem. So here, we don't have any opposites. I have a positive 1x and a positive 1x. I have 3y and a negative 1y. None of those are opposites. So my choice here was to multiply the second equation by 3. If I do that, I will have a positive 3y, and then I will have a negative 3y when I multiply by 3. The big key here is, since I'm choosing to multiply this one by 3, all 3 of those pieces have to be multiplied by 3. You can't just do the y's. If you just do the y's, it's all going to fall apart on you. So I multiplied everything here by 3. So I brought my equations over now. I didn't do anything to this one, so I still have x plus 3y equals negative 4. But I did multiply this one by 3. X times 3 is 3x. Negative y times 3 is a minus 3y. 4 times 3 is 12. Okay, so I multiplied it, and now we have opposites. Again, multiplying here by 3 here is legal because I'm really multiplying everything on both sides by 3. Now, it's time to add. I didn't put an addition sign in here, but I can. There we go. Notice x and 3x makes 4x. 3 and negative 3, my y's are going to disappear. They're gone. So I didn't even bother to write them in there this time. And then negative 4 and 12 makes 8. I then chose to divide both sides by 4, which gave me x is equal to 2. Okay, so there's my first part of my answer. I then brought the 2 back, and this time I chose to plug it into this second equation. So I plugged it in for x. 2 minus y is equal to 4. I subtracted the 2 to get rid of that. I'm going to be really careful here because of that minus sign. Don't lose it on the way down to here. Okay? It's really easy to do. You end up with y is equal to 2. You get the ordered pair 2, 2, but it wouldn't be correct. So we really need to be careful. Make sure we don't lose that negative sign. So I have negative y is equal to 2, which means that y has to actually be a negative 2. I'm basically dividing both sides by negative 1. And there's my ordered pair, 2, negative 2. All right, let's do another one. All right, here's my next example. I still have 2 more after this, so there are a lot of examples here. I'm starting with 2x plus 3y is equal to 8, and 3x plus 2y is equal to 7. So you'll notice we don't have any opposites here. And this time, it's going to be really kind of messy if we try to multiply 2 by something to get 3, or 3 by something to get 2. So this time, you'll notice I am multiplying both equations by something. So what I'm asking myself is this. I'm going to pay attention to the x's. It really doesn't matter. We can do either one. What could I Sorry, let me try that again. We want to multiply 2 and 3 by something each so that we end up with a number that they could have in common. 6 is the number that we could get to. There we go. I finally managed to spit it out. So 2 times 3 would be 6. 3 times 2 would be 6. So you notice I have 3 and 2, but I also threw in a negative on this 3. The reason is because I need opposites. If I just do 3 times 2 and get 6, and 3 times 2 here and get 6, they're both going to be 6. They're not going to be opposites. So one of the two, and it doesn't matter which one, but one of them needs to be a negative. So I did the top one with a negative. 2 times negative 3 gave me negative 6x. 3 times negative 3 is the negative 9y. And 8 times negative 3 gives me the negative 24. For the second one, 3 times 2 gives me 6x. 2 times 2 is 4y. And 7 times 2 is 14. From there, I proceed just like I did with the other examples. I add. My x's drop out this time. Negative 9 and 4 makes negative 5y, and negative 24 and 14 is negative 10. We divide both sides by negative 5, and we end up with y is equal to 2. There's the first half of my ordered pair. Or I guess technically it's the second half. So then I'm going to plug it in. Again, I chose the second equation. I plugged it in here. So we have 3x plus 2 times 2. I plugged in the 2 for y. 2 times 2 is 4. I'm going to subtract 4 from both sides, which gives me 3. Divide both sides by 3, and that gives me x is equal to 1. And we have an ordered pair, 1, 2. Loads of fun. All right, almost done. 2 more examples.